Hey everybody! The purpose of this video is to get you some solutions to the outliers data set. Here's the data set from that quiz. I went ahead and dropped it into Excel because, let me make it a little bit bigger. I think you guys can see it a little bit better. You can use your TIs, of course. I said use your TI for sure, but you know what? I thought this might be kind of a fun way to introduce you guys to how to do a histogram in Excel. I've made a video for it before, but this is actually kind of a nice alternate way of doing histograms if you don't want to use your TI. So with Excel, it's kind of the same thing as with your TI, except you do it backwards. Like instead of just hitting zoom 9, there is no zoom 9 in Excel. What you have to do is you have to kind of decide what your groupings want to be before you get to them. Now I put the data in order for you. The lowest is 0 and the highest is 1441. I'm going to go and make the graph first. Since it's 0 to 1441, I'm thinking I'm going to go 0 to 1500 by 50s. Let's see what that looks like. So if I go 0, 50, 100, and here's something that's cool that Excel will do. It'll actually, you can drag it down like this, and you can let it go all the way down, and it'll keep the pattern going. Now, something that you might, when you're using Excel and you're making a histogram with Excel like this, you don't actually put the last bin in. The last little bar will be anything over 1450, which will pick. Actually, technically speaking, I can stop at 1400, can't I? Because 1441's right there. So you don't need to put a 1450 in because 1441 will be over 1400. So you don't actually have to. To indicate that. Now this would be, technically speaking, your I want to put this in parentheses, your X scales. Your X scales are 50s. And what I'm about to do now are your Fs. Okay. Now this is actually called the frequency command, but here's how you do it. It's kind of goofy, so watch this carefully if you want to repeat this again. You have to left click and hold as you pull down all the way, including one past the 1400, because you do want to have a data point in there. You do. Now, I got that all selected. In the formula bar, you type equals. Now, this is where it gets a little tricky. Frequency, left parentheses. It asks for the data array. This is all your values right here. Then you hit a comma. Then it asks for your bins array. So you select all the bins, all down to 1400. With me so far? Then you close off the parentheses. Now this is the challenge. This is an array command, which means you have to hold down the Shift, Control, and Enter keys all at the same time. And here we go. Boom. There they are. There they are. There's 1, 0. There's no 50s, 100s. There's nothing from, there's one number from 0 to 50. I guess it's the 0. There's a 50 to 100. There's nothing there. 100 to 150, nothing. Looks like there's something from 200 to 250. Yep, right there. Those guys right there. 200 to 250, 201, 212. 3 from 250 to 300, and so forth and so on. Here they are. So that just counted them all for you. So now you've got your data in here. Good enough so far? That was a lot. You might have to go back and rewind that one and watch it a couple times. But that's the quickest way to get a frequency distribution off of Excel. Now, to get the actual histogram, all you got to do is select your data like this. Okay, select your data, go up to Insert, and then they call it a column chart. A 2D column chart will do just fine. And there it is. There it is right there. Now, I don't want to make this be a quiz about how to make a histogram. I mean, you can do all kinds of things with this histogram now that you've got it. For example, the first thing I would do is get rid of these labels and replace them with something meaningful like 0 to 50, 50 to 100, 100 to 150, 150 to 200, and so forth. That's the first thing I would do. The next thing I would probably do is adjust this data series so that there was no gap. And I'd probably want to change the border so that it's a solid line in a different color than you can have a lot of fun with this one. I mean, you can really get in there and mess around with the options on the histograms. I don't want to do that right now. Maybe for a later video. And if you're really interested, of course, you can always email me or ask me. But what I really wanted to do was just get a look at the data, and it looks roughly bell-shaped. I mean, you got obviously some holes and some gaps, but whatever, it's just about a bell shape, which tells me that we can use any method we want to find outliers, whether it's the interquartile range, whether it's the mean and standard deviation. So what I'm going to do is I'm going to just start creating some statistics here. Your mean is the average. So these are the same commands we used in our first exam. It's the average of all of these bad boys. So this thing has an average. It looks like the average is right around here, whatever that would be, 13th bin up, about 575. Standard deviation is the STDEV of the whole shebang. There it is right there. And now what's cool about it is you can call the ranges the high. I'll do low and high. If you're setting up ranges, your low would just be equal to the mean minus 2 times the standard deviation. So anything under 98 would be considered low. So the 0 would be an outlier using 2 standard deviations. Okay? The high would be anything mean above 2 standard deviations. So anything above 1,052. So actually by those two measures, these guys right here are outliers. So I'm going to color these. Boom, boom, boom. We're going to color those. How can we do this? Yellow. I'll make them yellow and blue make green, right? So those are the yellow ones. So what we'll do is we'll have a little key here. Yellow is outliers by the standard deviation method. I didn't spell that right. Or what cell am I in right there? Not outliers. Outliers by the standard deviation method. And what we'll do is we'll go ahead and maybe we'll just merge all these cells together. There we go. Beautiful, beautiful. So there's one way of looking at outliers. But the other way you can do it, of course, is actually by just grabbing interquartiles or quartiles. So I'll do Q1 and Q3, and then I'll do the IQR here. Q1, here's the command for quartiles if you want to use it. If you're looking up at the formula line up here, it's quartile spelled out. Then you grab the row of numbers in there, comma 1. That will give you the first quartile, which is at 436.25. The third quartile is exactly the same, but you use comma 3 instead. And the interquartile range is the difference of those. That one minus that one. Boom, 302. So 1.5 interquartile ranges. IQRs, whoops, let's make them all caps and spell it correctly, is going to be equals 1.5 times this number. Okay, so now I'm going to color this yellow too right here because that's the analysis on this one. Now we're going to do it low and a high down here. Okay, so the low, now this is where it gets a little bit tricky. I made you calculate these once in class manually, and we haven't done it since then. The low would be equal to this distance below Q1. So it would be Q1 minus 1.5 IQR, which is a negative number, which means if anything was truly unusually low using this mechanism, it would have to be negative. We don't have any negatives, so that means nothing is truly low. It's a beautiful use of logic right there, isn't it? High is kind of the same thing. You start at Q3 and you add to it that bad boy. Anything over 1,192-ish, and we do have one of those, that guy right there. So we're going to color him green, and we're going to be clever because we're intelligent, and we're going to say anything blue is outliers by the IQR method. And because we're clever, we know that blue and yellow make green. So 1441 is an outlier no matter what you look at, no matter what method you're using. 0 and 1068 are outliers due to 2 standard deviations. And I guess that kind of makes sense. I mean, obviously this is one of the two. Oh no, the outliers are both out here, right? 1068, they're both out here. No, they're not. That 1068 is way back here. Because we're going by 50s. Yep. So this guy's unusual, that guy's... So you know where 2 standard deviations lie. They lie right here. This is where that axis would really come in handy. And again, we'll develop a quiz around making a histogram one of these days, but not right now. It's not the time to get into that. So hope this helped, and yeah, hope it helped, and we'll catch you guys around.